Hello, everybody, and welcome to the Practitioners Unplugged podcast, where we dive into real-world stories and strategies of manufacturing digital transformation. Join us as we hear from thought leaders and innovators who are driving change and shaping the future of Industry 4.0. Whether you're a seasoned professional or just curious about the future of manufacturing, this podcast is for you. Today on episode 5, we're honored to have Bryan DeBois with us. Bryan brings over 25 years of experience in industrial automation backed by a solid foundation in computer science. He currently serves as Director of Industrial AI at the Rovisys company, where he leads innovative projects that are transforming customers' businesses. Throughout his impressive career, Bryan has developed extensive expertise in MES systems, historians, data strategy, business intelligence, and ERP. His deep understanding of these areas has made him a sought-after leader in driving the force in the field. We're thrilled to have Bryan with us today to share his experience. Welcome to the show, Bryan.
Thanks for having me.
No problem. No, Bryan, about a month ago, we spent some time on a panelist discussion at a conference where you started to give your perspective on a couple different things. So, after talking with you, I really enjoyed your experience, your approach on that, and wanted to get you on the show. So thanks again for joining us.
Yeah, happy to be here.
Awesome. So can you take us through a little bit about what you do on a day-to-day basis?
Yeah, sure can. So in order to explain that, I probably should talk a little bit about my employer. So I work for Rovisys. We are a system integrator that focuses on that manufacturing and industrial space. We operate under, we typically talk in terms of OT. So for your listeners who may not be familiar with that term, OT is operational technology, and is a term that, from my research, Gartner coined around 2006. Everyone knew what IT was, right? And they needed a different term to refer to what happens on the plant floor. And so they coined this term OT. And so we're an OT system integrator. Rovisys has been around for 35 years. And in that history, we started out as a very traditional control systems integrator, right? So we did PLC, DCS programming, SCADAs, HMI, the types of systems that make a factory run. And then probably around the late 90s, early 2000s, we really started to move up the value chain and start focusing on information solutions. And I started at the company around 2000 and was mainly focused early in my career on historian implementations and MESs. You couldn't just go buy an MES off the shelf. You had to. So we were building custom MESs, and that's just what you did. A lot of data integration between these different systems. And then over the years, we continued to add value and we continued to grow as an organization. We're now 1,400 engineers globally, I think 18 locations around the world. And about 5 years ago, though, we had hit our 30-year anniversary as an SI, and we said, what's next? And we saw that, some of these skill sets that we had, like the traditional control system integration, some of that was becoming a commodity. This stuff was getting smarter, and you could configure a lot of this stuff without having to do explicit programming. And so we looked at what was next, and we came up with a couple different initiatives, but one of those was industrial AI. So 5 years ago, we created this industrial AI division. I was fortunate enough to be named the director of that. And so since then, we've been doing this industrial AI. Now, what's been interesting is because we have that 5-year head start at this industrial AI thing, we are now being recognized amongst our peers as a thought leader in the manufacturing space around AI. And so it's been really interesting to go at this. Now, when I started 5 years ago, I'll admit I was a little skeptical. I said, is it too early, right? And my concern was that I would go into these meetings and I'd kind of be, I'd say I'm the director of industrial AI, and I'd be laughed out of the room, right? Like, no, we're manufacturers. We're not ready for that right now. That's all goofy sci-fi stuff, right? What I found very early was that not only were we not too early, we had customers that I would go in and they'd bring in their data science team. I'm like, you guys have a data science team. Well, all right. So maybe we are kind of hitting when the iron was hot. Now, of course, then you fast forward to November of 2022 and ChatGPT suddenly comes onto the scene, and suddenly now AI is back in the news and everyone's talking about it, and it's being recognized for how revolutionary it is. And so as soon as that happened, 2023, my phone's ringing off the hook, because now all of a sudden these manufacturers are calling me and saying, my CEO, my CIO said, I've got to be doing something with AI. What can you give me? And so, that initiated a lot of these conversations. And we can talk about the role that generative AI, which ChatGPT is broadly called generative AI. We can talk about the role that generative AI has in manufacturing, but there's a lot of other types of AI that are kind of are ready today, and that we're typically tackling these AI projects with those well established approaches today.
Yeah, and that's a great point, right? So when things go mainstream, and this was kind of the same thing with IoT, people didn't know what it was until you could start to connect like your thermostat and all
Right.
these things in your house. And as soon as that consumer awareness comes in, it seems like the mad rush to these products and solutions and things is just like it starts to go everywhere. Yeah, and I know everybody's like obsessed with ChatGPT and Gen AI and everything it can do, but there is a rich history of beneficial, let's say, non generative AI on the manufacturing floor. So can you take us through? Let's get out of the generative AI because that's what everybody talks about, and every marketing is AI this today. So what are the practical applications where you've seen the most value? Like what type of applications? And this is more on the OT side, right? Not the business
Yes.
systems, but
Yes.
it's a completely. I think people need to understand that it's a completely different methodology. And where I really like your background is you have that data science expertise with the OT foundations and
Mhm.
understanding. And I think that's the big miss that we see from a lot of companies is trying to have data scientists lead an OT AI strategy. So where do you feel like we're very mature on the industrial space, and what are some of the successes that you've been able to deploy?
Yeah, for sure. So, we typically talk in terms of three high level buckets for industrial AI today. The top level bucket we've labeled traditional AI, which sounds funny because we've got customers that are just now starting on an AI journey. But the reality of it is that we've actually been able to leverage AI in the manufacturing space for 15, 20 years now. And so those are the technologies we put in the traditional AI bucket. And that's subdivided into kind of two categories. One of those is what's called unsupervised learning. And unsupervised learning in our world is really just anomaly detection. And I mean, there's been anomaly detection systems running in the OT world, like I said, for a long, long time. And effectively, what that looks like is you hook up a model to the process, and it does not require any a priori knowledge, and it starts monitoring the system, and it learns over time what normal looks like, and then it can tell you when things start to look abnormal. Now, importantly, it can't tell you why things are going abnormal. All it can do is say, this doesn't look the same as it did yesterday. And it can typically tease those types of things apart, those correlations apart, well before a human operator would realize that things are going abnormal. Okay, so that's anomaly detection, that's unsupervised learning. The other big category of AI that's been around for a while, traditional AI, is what's called supervised learning. And that is where we take large volumes of very clean, very correlated data. We feed it into an ML model, and it learns to predict a value. Now, importantly, it can only predict one value. So in the case of predictive maintenance, it can predict, this piece of equipment is going to go down in the next X number of days. In the case of predictive quality, it can predict, here's what the final quality of this batch is going to be. And it'll predict it well before the batch is completed. But that's all it can do, is it can make a prediction. Now, built into that is an assumption, and built into supervised learning is an assumption, and that's that somebody knows what to do with that prediction. So if I can predict with 95% confidence that this batch is going to be off spec or of low quality, does somebody know what to do with that information? Does somebody know how to do the rework? Does somebody know additives, increase the pressure, or decrease the temperature, whatever it takes to bring that batch back into spec? If nobody knows how to do that, then you have to turn to the other major category of industrial AI that's in use today, and that's called autonomous AI. And what autonomous AI does is it does, frankly, what most people want AI to be able to do, and that's that it makes a decision. So it actually looks at the state of the system and it says, based on everything I'm seeing, here's your next best move. So it doesn't have to wonder, you don't have to wonder about how to fix that off spec batch. Autonomous AI actually will plot a course and get you back to making on spec product. It's actually able to build long term strategy like a human being is. In a lot of ways, it looks like magic when you use it, but it really does work in that way. The last and the third category of industrial AI, and this is the one that is emerging, is this generative AI. And I've got some, my strong opinions on generative AI, and we can get into all of that. But We are starting to see, obviously, generative AI start to make inroads into this manufacturing space. But autonomous AI, we think, is the thing, and it's already running in plants, so it's not like bleeding edge. But we think autonomous AI is the thing that's actually going to be an inflection point and make the biggest impact in the short term, short to medium term, in the manufacturing world.
Yeah, and I happen to agree with that because that closed loop autonomous process control, I believe, is kind of like the holy grail of some of this other stuff. There's a lot of other
Yeah,
technologies out there that people are chasing, but if you can really detect and correct in real time, that's where the value is.
yeah,
And I always look at, deploying AI strategies, and I call it like an arc mentality. So the first one is an advisory capacity. Is the output of what we're getting correct? Yes or no? Then we go into refinement. Once we're comfortable with the refinement period, then we get into control. But it doesn't seem like the refinement ever really stops. So how do you guys take on model refinements and continuous improvement once you develop like control algorithms and models within there to make sure we're not hallucinating?
yeah. Well, and so, and it's funny, but I've never used that term before, but I like that approach, arc. But so
It's
what we typically.
patented.
Oh yeah.
No, no.
Uh, the way we typically approach it is we put these systems in place as what we call decision support mode first, and that's where, very similar to what you're talking about, where it is not doing the direct control. There's a human in the loop, and as as we call them brains. A neural network trained with this autonomous AI approach is called a brain. So as these brains make decisions, those decisions then get surfaced on, we can either put them right on the HMI or we can put them on a web-based display right next to the HMI. And it's saying, okay, look, based on everything I'm seeing, here's the set points I would use. And we got this running on a glass bottle manufacturer right now. And so, they've got their HMI and it shows right on it, here's the set points that the brain thinks you should use. And then they have two buttons underneath. One is accept, and if they hit that, it shoves it right into the set point and sends it down to the control system. The other one is reject, and if they hit that button, then they get a box that pops up and it says, okay, you didn't like what the brain had to say. Why didn't you take its recommendation? And they'll go, well, it didn't realize it thought we were in this state. We're actually in this state. So, okay. And so then we use that feedback. That's the refinement. We use that feedback then to retrain the brain to make it better at recognizing what state the system's in and making better at making decisions. That process can vary based on each customer. Some customers, maybe they only want to run that for 3 months in that mode. Some maybe 6 months, maybe longer. But the point is that after a while, and we're, of course, we're tracking all of this data. After a while, we start to see that no one's rejecting; they're just accepting everything that the brain is saying. And maybe it's been months since the last time that they've rejected a decision. Now we know we're comfortable. The customer's comfortable. Now we start talking about going to direct control. But even in the case of direct control, there's some things that we can do, because that can be really kind of scary. Like, well, what happens if the brain, does something crazy or whatever? So there's a couple of things I say to address that. One is that the brain can't do anything that human operator couldn't do. Right. So, and I mean, we've talked about, and I'm sure your customers know about the the massive labor shortage that we have in the manufacturing space, right? So we've got high turnover in these operator roles, and so you had a guy that maybe had 2 weeks of training and had only been here for a month, and that was the person you trusted not to blow up the plant. I got a brain that by the time this brain is done training, it's as if it's a 20-year operator. Okay, so it's savvy. So keep that in mind. You trusted the human operator. I can't do anything they couldn't do. But the other aspect is that we're in the digital world here. So if you've got a knob and the human operator could turn it from 0 to 100, but you tell me, that was fine for the human, but I only want the brain to be able to work between 20 and 80, fine. So I can put those constraints on it too. We also can constrain it in terms of the states that it's actually allowed to work in. So let's say that a lot of these projects, it's like, well, we've got 80% of our product is this one SKU. We really just want the brain to be able to manage steady state on these 80%. The 20% of products we only make once in a while, we don't even need the brain to kick on. So we can do that. So we can say, okay, the brain's only going to work here, and then when one of these SKUs come in that's is an oddball, it'll just automatically kick off, and then the human operator can take back over. So there's a lot of ways that we can we can restrain what it does and make sure that people feel comfortable with it once it's deployed.
Bryan, as you go out there and engage with companies, and what are the expectations of AI? So you're familiar with the whole hype cycle. Give us a sense of the expectations reality gap.
Yeah. No, it's a good question. I would say the expectations right now are high for AI. And that's okay in some regards, because with the autonomous AI, we're actually able, we're going after, typically $1 million a year annual savings. That's the type of ROI that we're going after with these types of projects. So it's okay to have some pretty high expectations from that standpoint. But to your point, they're also used to dealing, they all now at this point have played around with ChatGPT. They've seen, some of this generative AI stuff, and it's very cool what it can do. And so they are kind of expecting like Skynet level of like, so we're just going to hook this thing up and I can, and it'll just run the thing and without making any mistake. Like, no, we're not there yet. In fact, in a lot of ways, while generative AI is driving a lot of interest towards AI, which is great, it's also muddying the waters because it's just tricky. It's done a very good job of impersonating human beings. But one of the things that is important to understand about generative AI is that it does not understand anything about what it's saying. It does not even understand what the words mean. It's literally just good. It's a autocomplete on steroids. It's really good at guessing what the next best word should be, without understanding really anything about the underlying logic of what it's saying, understanding anything about language, really. Even it doesn't really understand language per se. It doesn't understand what the meaning of those words are. It can just guess the next word. And that gives this impression that AI is much smarter than it is. When we come in and what we do is we take it a very deliberate step-by-step process, and we build, autonomous AI in particular. It requires some sort of simulation. It learns by doing. And so we've got to build first. We've got to sit down. We've got to build some kind of simulation of that part of the process. And then the autonomous AI is we're going to let it loose on that simulation. And it's going to learn how best to, like I said, by the time it's done training, it may take a day to train, but it'll be like it learned for 20 plus years. And so it will have learned all kinds of different, it was a great story. We had one of these, and we were validating the brain before we ever even put it into production. We were validating the brain. So we're in a conference room and the brain is operating against the simulation. And the brain does something, and we had a 25-year expert at the process that was sitting next to us, and he's going through and he's watching the brain make decisions. He goes, yep, that looks good. Yeah, oh yeah. And then it goes to a thing, and the brain makes a decision. He goes, huh. He's like, well, I've never actually done it that way, but that actually makes sense. That's actually a really good way of doing it. So, that's really cool when we get to those innovation points. And so now we've got a brain, with that customer that can outperform their best experts. So, that's pretty cool. That when you talk about setting expectations, like we're doing some pretty cool things with it. So again, that hype cycle, it's tough. It's tough. It's like we want to temper some of those expectations, but at the same time, we're able to deliver some pretty advanced stuff. So, you got to kind of walk that line.
Yeah, it feels like generative AI kind of muddied the waters quite a bit, right?
Yeah.
Because even before I get to AI technologies, if I think about, I've gone through this journey of understanding the behavior of an enterprise, the behavior of a supply chain, the behavior of a plant, the behavior of a line, the behavior of an asset. And, the human brain has gone through, at least my human brain has gone through a process of codification. And, the way I've codified, this, so you know of the, data, information, knowledge, wisdom, that spectrum. So in this codification process, I think of data, whether you want to call it data, knowledge, or information, but it looks like an onion. And so, at the outer layer of the onion is the value chain ecosystem, and the innermost layer of the onion is the asset. And this ties back to, some people are questioning, well, does the ISA 95 model is still valid?
Yeah, I have heard that. Yeah.
And, I think there is a case to push back and say, no, wait a minute. I think, you don't underappreciate the way we organize information and knowledge. Because my question is, as I've gone through my learning process, the question that comes to my mind is AI learning the way I am learning? Or is it completely, it's like people from two different dimensions come in and try to understand the world, and right? But
Yeah.
regardless of what dimension we see it with, we need to get it right.
Yeah, exactly. Well, and so let's address that a little bit. So with autonomous AI, it is learning in the way that humans learn, right? In that it experiments, it tries new things, it fails. It has a reward and penalty function that we give it. And so we penalize it when it moves further away from its goal, and we reward it when it gets better at doing whatever the part of the process, making glass bottles, or even we've done projects where we've used autonomous AI to build production schedules, right? So, oh, great, you built a good production schedule. It's gonna optimize and be efficient. We're gonna be done even faster, and we can push more. This was for a paint manufacturer. We can push more gallons of paint through, right? So we reward it then, or we penalize it. Oh no, that's a terrible production schedule, right? And so during that learning process, it's learning like a human. Generative AI, and I sound like a generative AI hater when I go on this rant, but I'm really not. I really love generative AI, and I use it a couple times a week at least, right? And I love the potential that it has. However, to your point, it's not learning like humans learn. It's learning statistical correlations between words. That's not what humans do. And like I said, it doesn't understand the meaning of those words. And so one of the things that's led to, and people are realizing it now, right? When they mess around with, they're called LLMs, large language models. So when you mess around with LLMs, like ChatGPT, what you find is that it has a tendency to hallucinate. Right? So for your listeners who may not know that term, what does hallucinate mean? It's when the LLM just makes stuff up out of whole cloth, right? You could call it a statistical anomaly, but basically it's guessing the next word and it just starts to go off on a tangent and it's making stuff up. And the challenge with it is that everything it's saying is, in a lot of ways, unless you're an expert, is indistinguishable from the truth. And so in the classic example that I show when I present this, at conferences, is I took a screenshot of this. So I asked ChatGPT, and this was just a couple months ago. I asked ChatGPT, I said, can you list out the names of the 13 dwarves from the classic Disney movie, Snow White? Now, we all know there weren't 13 dwarves, right? There were 7. And so what it does then, and then I show the results. What it did is it said, yeah, I can absolutely do that for you. And so then it creates this numbered list. And it lists, and the first 7 are, Sleepy and Doc and all the ones that we know, and Grumpy. And then it creates 6 more names, and it just made them up. And they all sound completely convincing. It's like wimpy, and it's wheezy, I think is what I'm, and if you didn't know any better, if you didn't have that a priori knowledge, you would just think, oh, okay, yeah, there's 13 dwarves, right? Now, when you do that in the case of generating an email to a colleague or generating marketing copy for a website, it's kind of funny and everyone laughs. You may email it around to your buddies like, look what it made. But if you do that on the plant floor and it's a maintenance person who doesn't have any idea, doesn't know any better, you could kill somebody. You could blow up the plant. And so I'm very adamant that if you want to use generative AI, if you're a manufacturing and industrial customer and you want to use generative AI to solve some of the knowledge problems you have in the carpeted space, by all means do it, right? You want to optimize and organize your data up there and your documents, and great, love it, do it. But it is not yet appropriate to use on the plant floor. Those hallucinations could be deadly. And what bothers me is the number one use case that I see these AI vendors who oftentimes have no idea that this is their first time coming down into our world, in the OT world. And one of the first use cases that they pitch is they go, hey, I can solve your maintenance problems. Take all your maintenance records and all of your SOPs and all of your manuals and everything about all your assets and put it into this LLM, and we'll build a chatbot. And we're going to put it in front of that inexperienced maintenance person, the one person who wouldn't know any better to question what it's telling you. And this person's going to say, hey, this machine is down. How do I fix it? And the chatbot's going to say, now, whether or not it knows the answer or not, the chatbot's going to say, I know exactly how to fix it, because they're programmed not to say, I don't know. They can't say, I don't know. So they go, no, I know exactly how to fix it. You do this, you torque this bolt, you put this in here, and you rev the engine, and you could kill somebody, right? So no, I don't think it's appropriate to use generative AI on the plant floor yet. It's not to say that we're not going to fix this, but guys, I mean, before November 2022, outside of a very small group of LLM researchers, no one had even heard of generative AI. So we're not even 2 years. I guess this is the second year that the world has even known that LLMs exist. We're going to fix this. The LLM researchers understand the problems with hallucinations. They will fix it, but it is not fixed yet. And so I'm just very adamant that we need to be very careful about adopting that. Let's leverage the existing established, well understood AI that we're using on the plant floor today. Let's use those things. Let's have autonomous AI is like magic when it works, when you see it working. Like, let's leverage those types of technologies today, and let's keep a strong eye on generative AI and where it can go. But no, we're not implementing it on the plant floor today.
I just want to address something that you had mentioned before, right? So we talked about great successes, but one of the key things that you hit on that we didn't really dive into is really that organization and contextualization of data at the beginning. So typically we see everybody just wants to jump to the end result, but they're always missing history and context. So where do you see these projects kind of break down? Hey, we have this push from our CEO. We need to start doing AI projects. Like, where do they fall apart?
Yeah, and you know, it's funny because I sometimes say that I always get to be the bearer of bad news, because I come into these meetings and everyone's excited about AI, and I'm excited to talk to them, and we're going on about AI. I had this happen with a semiconductor manufacturer, and so, you know, I give the whole AI pitch, and they're excited, and I'm excited. I go, okay, now let's pivot here, and let's talk about what your OT data infrastructure looks like, right? Do you have a historian? Do you have, as you mentioned, like, and even today, just having a historian isn't enough. Oftentimes, have you done anything to contextualize the data in that historian, or is it just a bunch of tags, you know, time series data? And so what have you done in that regard to get yourself ready, right, to take on an AI project? And so I asked that semiconductor manufacturer, and they go, well, what we have is we kind of have a bunch of just standalone cells, work cells, and nothing's really networked. And we got like each work cell has kind of its own little, you know, access database that it records data into. And then they go and they turn around and they go, so this AI, is it able to go and find all that data and in all those access databases, and it's able to put it all together? I'm like, no, it's not even close. So then we end up pivoting, and then we end up starting to talk about data readiness and data infrastructure. And so we actually are doing more infrastructure projects now than I've seen in the history of the company. We're doing everything from networking, getting those different disconnected work cells, getting them networked, getting them updated, getting the existing network infrastructure. Man, when I started my career, like, it was the Wild West, right? It was the OT engineers had full control over everything that happened in the plant. And if you needed two machines to talk to each other, you went to Office Max and you bought a switch and you just plugged it in. Yeah. Like, there was no governance. The IT department had no idea what was going on down there. I'm not saying we want to go back to that. Like, the IT-OT convergence, a big part of that was bringing some of the discipline that came from that IT world down into our world. That was a good thing, right? In 2009, when Stuxnet happened, this was the first ever control system virus that the world had ever seen. Like, it was an eye opener, right? So we needed to do that stuff. So those efforts to optimize and to modernize that IT or OT data infrastructure and OT networking, all of that is worthwhile. So we're doing a lot of those projects with an eye to an AI future. Now, one of the things that's kind of interesting, and that I talk to these OT engineers and OT experts on the plant floor is I tell them, like, you can get all of those upgrades, the 20-year piece of equipment that you could never find. Nobody in corporate could ever find any funding to update this machine. You can get that now. You just need to tie it to this AI future they want to get to. And I've had customers who have said, you know, this is the carrot. The AI is the carrot. That's what corporate wants to get to. So let's work backwards and let's get the funding now for all those projects, those critical upgrade projects and maintenance projects and modernization projects they wanted to get done anyway. Let's get the funding for that and tie it to that AI future. So it's a good thing, and it's pushing us towards this the true Industry 4.0. It's pushing us towards that, and suddenly this funding is magically available now to upgrade this equipment that was never available for 20 plus years, because corporate wants to get access to that data, and they want to be able to do that analytics, and their data science teams are hungry to get their hands on that data from the plant floor.
Yeah, and that's a great point, because we always see these people, we always see customers failing to be able to justify changing out like a PLC or network infrastructure. If I have old legacy Modbus or Modbus Plus networks, it's like, okay, what's the value? We're managing obsolescence, but now what? The only, caveat we have, or the only thing we can extrapolate is risk-based maintenance at that point. It's like, hey, if we go down, we go down. But yeah, now this data infrastructure is important, which kind of leads me back to that ISA 95 question that we had is it still relevant? Because I see a lot of startups which are just edge to cloud. But again, if your goal is lights out manufacturing, autonomous control, I don't think you can necessarily bypass that, because the PLC needs to make the decision. So what am I doing? Go into the cloud to try to pull stuff when I need instantaneous information? Like, what are your thoughts on the relevance of ISA 95 and these edge to cloud utopias that we keep seeing out there?
Yeah. I need to put more thought into it. I've heard recently these rumblings about, is ISA 95 still relevant, and should we move to a different model? Anytime you talk about throwing out, we're standing on the shoulders of giants. The people that put the ISA 95 standard together knew what they were doing. They knew intimately that how this stuff all works. And, Sri talked about layers, and I think that in any modern or in any mature organization and mature industry, you've got layers of abstraction. You've got layers that build on other layers, and there's value in that. And in particular, when you talk about DMZs and network segmentation, we built a security structure around the ISA 95 model, and we put very clearly in there a firewall breakpoint between the outside world and the plant, in the plant world, and the plant control network. And we did that very intentionally. And so now to start talking about breaking that down, breaking through all those walls, and just having a direct connection from the plant floor to the internet, I gotta say, guys, I'm not a big fan. It doesn't feel right to me. It doesn't feel like, kind of secure by default. And, I'm a big fan of trying to air gap as much as possible. Now, you can't completely, if you want to have some of these benefits of historians and stuff. So I understand we got to put very small holes through there, one directional holes, to allow that data to flow up from the plant floor so that we can get the benefits of all these analytics and stuff like that. So we're putting historians in the DMZ, and I'm okay with that. And then, piping that data and having gateways that then can relay that data up to the cloud. Great. Love it. But now you're still respecting the ISA 95 model, and you're still respecting all of those layers of insulation and layers of security down to the plant floor. I'll tell you, we don't really implement any system where you have to, if it's a critical type of decision, we don't implement any system where you have to have a round trip to the internet. We just don't. I've seen some cloud deployed MESs that are fine, but in those typically with those cases, the MES is not making real-time decisions about something that's happening on the plant floor. So the plant floor effectively can run for a matter of hours without a decision from the MES, can continue to run. I'm okay with that. I've implemented systems like that where the customer insists that the MES needs to be in the cloud. Okay, I get it. MESs are, they take a lot of infrastructure. So, okay, fine. It needs to go in the cloud. But then we've designed it in a way where the control system can run for a while without having to have that constant connection. I'm not convinced of this idea of having a constant connection to the cloud to be able to run your operations to make real-time critical decisions. So,
yeah, and I push back on, oh, sorry, go ahead, Trey.
No, I was going to say, so I'm actually a fan of biomimicry. And if you heard the term, it basically says, Mother Nature has been designing systems for millennia, and there are great ideas in the systems, she has designed. And so when you look at this, systems of system structure, back in 2000, Bill Gates coined the word digital nervous system. And ever since first time I heard of that, I was like, okay, that's something there. Because AI needs to be looked at within the context of a digital nervous system. And if you look at our own nervous system, we have 1 billion neurons, throughout the body and 1 billion neurons in the brain. But those neurons don't directly send everything to the brain. If you got 1 billion signals, your brain would just shut down.
Right.
But we have systems, the nervous system is designed in such that, you have, like when you go to sleep, you don't stop breathing, So there are some systems are autonomous, some systems
We
are
got safety systems built in there. We've got things like the blood-brain barrier that protects our brain.
Exactly. We got fight or flight designs.
Yep.
I think similarly, we should look at the enterprise, the business, and say, how should this business respond? I mean, some responses are, need for more real-time autonomous loops, etc. And that otherwise, I feel like for 20 years we've been, building Frankenstein architectures on the shop floor. And are we going to build Frankenstein architectures on the cloud? Right?
Yeah.
There's a need to step back and, put some, do this in a smarter way. Right?
I 100% agree. And so one of the things that we do whenever we're training a model, we typically do use the cloud to train, because I've yet to see a customer that has an on-prem data center that's got the compute power to be able to train as fast and as the cloud. So we do the training in the cloud, but then those models get disconnected from the cloud and they get deployed into either the DMC or the plant control network, so that they can respond in real time, so that they're isolated from the rest of the world. And absolutely. I think that there needs to be a lot more thought put into in a very deliberate approach to how we are going to architect these systems in the future. And so, no, I'm not one of those knee-jerk, let's throw out ISA 95. I think that those layers of protection, layers of decision-making at each, so the control system's making very fast decisions, and then you've got the MES that's making slightly slower decisions or longer, time frame decisions. And you got the ERP then, their ERP's working on time frames of weeks, months, and so I think that that's the right way to approach it. And then the cloud becomes more of a support system. It becomes a way of doing offline analysis, a way of making all of those components better and then deploying it later down into the system. I think that's the right way to think about it.
Yeah. I think we're getting a lot of mix up in the term MES. Like what we would understand it is more like manufacturing execution system, which is your quarterback, to like a manufacturing information system. And I think some of the big cloud providers are coming in showing this utopian manufacturing information system with this edge to cloud infrastructure. It's like, okay, you have all this data. How are you going to respond now? And then it just becomes like blank stares, right? So I don't think about bypassing it. And I've seen a lot of discussion on LinkedIn. Hey, you should do this. There's minimal infrastructure. I'm like, okay, well, why? Well, you need to start somewhere and you have to do a proof of value. I was like, yeah, but if your goal is to do like closed loop autonomous control at some point, you're going to have to re-engineer the way you did it. So why are we taking that step where we're trying to get the short-term value of just information in the sky? And then when we want to actually have value and bring that data to make a decision automatically, we have to re-engineer everything.
Yeah. And I mean, now, so we've kind of been ragging on this. Let's talk about where the cloud can be really useful. I've done projects where we did enterprise deployments of all these lower level systems. And then, we fed all that data up into these amazing dashboards. We did a project for a midstream pipeline company, and we lit up, their vision was to build a NASA style control room that would be able to have complete visibility into their entire enterprise. And we did it for them. And we built it actually using the Pi system. And we had all that data flowing into all these sub Pi systems, and then they're all coming into an enterprise Pi system. And then you had these amazing dashboards. And so they could see their entire enterprise and leveraging the cloud. They could see their entire enterprise in one view, and then they could drill in and go all the way down to a single pump. They had about 1,500 pumps across this across their entire network of pipelines, and they could drill down into a single pump, and we had predictive analytics on every single one of those 1,500 pumps. I mean, that to me is the right way to leverage the cloud in a near real time type of thing. And you're still then able to respond to problems in near real time, but you've respected all of those layers of security and that we've built up over the years.
Yeah, I agree with that. That enterprise visualization, especially with this like labor gap right now, a
Yeah.
lot of like larger companies kind of need to centralize those engineering efforts and operations because I can't put engineers regionally, locally at every single plant.
Yeah.
So really bringing that together, and that's where I do think I agree with you on that. The cloud plays that pivotal role.
Yeah.
Now, you had mentioned Pi there. I think Pi is one of the most underutilized tools kind of in the marketplace right now, and I think it plays a pretty a much needed, it fills a much needed need into this AI journey. So what is your, I don't want to get into products, but I think it's a great tool for that because it gives you the organization contextualization. How important do you think Pi is in this AI future?
Well, I mean, and we, like you said, if we get away from specific products, I think if we talk about historians and it more generally, they are absolutely critical. In fact, if I go into a company and if they have simulation already, we can maybe do some things. But if they don't have any kind of simulation and they don't have a historian that's collecting data, they can't really do anything with AI. So we now have to go back and we need to go do a data infrastructure project, put in a historian for them. Oftentimes it is Pi. And we need to start to collect that data. We need to contextualize that data. And we need to start to build that historical record that we can now go back and we can train that AI off of. If you don't have that, you can't really do anything. And that's one of the things that frustrates me when I see these AI vendors, predictive maintenance. Again, they've been selling predictive maintenance to our industry for a long time. And there's just a lot of hand waving that happens around the data aspect of it. But we know that if you go in there and they don't have all the data in their historian, you're not going to be able to successfully predict when this piece of equipment's going to go down. And moreover, even if you have the process data in the historian, if you can't marry that to data in your maintenance system that says here's why it went down and what happened, those things are all prerequisites to a successful predictive maintenance project. And I mean, you ask these vendors and it's just a lot of hand waving around all that. They're just interested in selling the product and they're not really thinking about what it's going to take to implement the project successfully.
Yeah, so to that point, like predictive maintenance, everybody wants to move to that. Now you had an interesting perspective on that. So what's really your thought on predictive maintenance? Because I think everybody feels like it's going to fix their equipment and prevent it from failing. Like, what are your thoughts on what's a good predictive maintenance strategy, or how do you come to see it, if I should even put that in?
Yeah, so a couple of things. First off, you have to marry a predictive maintenance system with an anomaly detection, because it's only going to be valuable if it can. It's not going to be able to predict anything that hadn't already happened. So if you have in the historical record that it failed this exact way, one or two times before, then yeah, you can typically build a model that can predict that failure. But other than that, you've got to marry it with anomaly detection, because it's going to try. You have to have some mechanism for it to recognize when things are going wonky. So first off, you have to marry those two things together. The other thing, though, is that with predictive maintenance, what are you really trying to do? You're trying to avoid downtime, unplanned downtime, right? You're trying to avoid unplanned downtime. And we all get that unplanned downtime is very expensive. If everyone's standing around, and it could be millions of dollars, right, of unplanned downtime. So it's very valuable to prevent that. But remember that if I can predict for you within 95% certainty that this piece of equipment's going to go down in a week or 10 days, it's going to go down. That asset's going to go down. Your only option is to move a maintenance window. Like your only option, what you're trying to do is you're just trying to turn unplanned downtime into planned downtime. That's it. So we feel like while it's valuable, there's other places that you can find more value. Predictive quality. If I can predict for you, you're making product every day. If I can predict for you what the quality of this product's going to be well before you've dumped all of that energy and all of that raw material and all that labor into that product, if I can predict for you that you're making garbage before you even get to the end. I had a manufacturer, they make airplane parts, and they've got these really expensive alloys. And they said a typical casting of one of these parts, it takes about 36 casts to make a single part. And they said every time we dip the ladle into the alloy, it's about $5,000. Now, so we built a predictive quality model for them so that by cast 5 or 6, we could tell them, you're going in the wrong direction. You're going to make garbage. So don't waste all of that money to get to the 36th cast, $5,000 every time you dip that ladle, and then have to melt the whole thing down and start over again, right? So I'm much more bullish on approaches like predictive quality and autonomous AI to find that ROI rather than predictive maintenance. I know it gets all the hype. I know that there's a lot of excitement around predictive maintenance, but there's only so much you can do with it. And again, it's very limited if you haven't failed in that specific way. And there's a lot of ways to fail. If you haven't failed in that very specific way, it's not going to be able to predict for you that you're going to fail that way in the future.
Yeah. Plus, I think it's kind of expensive just to unleash it onto your floor, right? You have to build a model for every motor, every pump, every whatever. I mean, there's some companies that have off the shelf stuff, but again, it seems like the workflow and the methodology behind it is really missing, and what the overall asset performance management strategy is. So we can detect it, right? Yeah.
I think that's a really good point. And I think that's also something that the AI vendors hand wave around. We've not been able to build these predictive models that really work across all your pumps. Like if you've got 20 different model of pump, you're probably building 20 different models, like ML models, predictive models. And like you said, you've got vendors out there that have started to ship ML models now, so that are tailored to their pump, and that's great. Okay, they're rotating equipment, their turbine, like, okay, that's fine, like that's good. But yeah, like you said, there's just a lot to it. It's a very expensive undertaking. And it's all, the AI vendors have a incentive to make it look much easier than it really is.
So Bryan, I want to build on this point, because there's a whole topic around AI at scale, right? Because if every AI project is a one-off, this is going nowhere. So the ability to create templates and scale and be repeatable. So again, without getting into the specifics of any product, what is the work done at the historization level to harmonize data, to standardize, build these templates? Because I think in order to do AI at scale, you need that layer where you can say, I have trusted consumption-ready data to feed the AI model, right?
Yes. Now, so a couple of things there. Our approach is very use case driven, right? And a lot of vendors don't want to hear that. They're like, just buy the thing and put it in and you'll figure out the use cases later. But we're very use case driven. And so there's an infinite amount of data that we can gather, right? There's no limit to the amount of data and new data that we can gather, and at different frequencies and whatever. So instead, we say, here's the use case that we're attacking. Here's the AI use case we want to go for. And then we work backwards and say, here's all the data that we're going to need to do that. Now, it turns out that when you build like you said, a very cleansed, a very correlated, an AI-ready data set, it turns out you can actually solve a lot of problems with it, right? So it's not like you're restricting yourself and you're going to have to start all over again. But let's figure out, a handful of use cases, and then let's work backwards and figure out what the data is. Now, then we are going to go through that whole process of making sure that all that data is contextualized, that it's all very clean, gaps in the data. We got to figure all that out. You got bad sensors. We do data science first to figure out all of that stuff. Oh, turns out the last 2 years of data, and we had this for a project, turns out the last 2 years of data that you had is not going to work for this AI project because this one sensor is actually bad and has not been collecting good data for the last couple of years. And they weren't looking at it because it wasn't a key part of what they were doing for the process, but it turns out to be a key part of what we needed to be able to build a successful model. So we do have to do that data science. There's no working around that. But it's more about, for me, I look at it as AI is in its early days in our world, right? So, but I've been around long enough that I can compare it to something that similar. And so when I look back, I see this as the early days of historians. When we first started putting in historians, they didn't have things like the, Pi system has what's called the asset framework, right? Where you can tie all these just rando tags and you can build assets around it. And then it has this ability to templatize assets, right? So now you can say a pump is a pump. We want it defined this way. And then we can, N+1, N+100, they're all going to be built the same way. You can templatize that. We take for granted that we've got all that kind of stuff now. We've got the ability to track events in the historian. We've got the ability to have, some of those lower level analytics and calculations we can do right inside the historian. We take that all for granted. I've been around long enough that when we first started implementing these historians, you didn't have any of that. And so we're in that early days. So it's the world of historians is a very mature space right now. We're in the early days of AI. So we don't have some of those disciplines built yet. We don't have some of those pipelines built yet. We don't know all of those skill sets yet that we're going to need. So in a lot of ways, it's very similar to the type of education that we had to do and training we had to do in the early days of implementing historians for customers. You had to teach them how to do all this. You had to have people who were going to sit down and become an expert in how to configure event frames and asset framework and configure these tools inside of the historian. It's the same way. We got to sit down and we've got to teach them how to use these platforms. Ultimately, our goal as a system integrator is for them to own the system. We want them to be able to solve. So we're going to solve the first 5 or so use cases for you, and we're going to show you what that looks like, to identify a use case, to work backwards, to get the data streams flowing, to do the data science around that, and then to build the model, and then to put it into deploy it in operations. We're going to show you how to do all that. And then we want you ultimately to be able to do the 6th one and the 7th one and so on and so forth yourself, because we've now built a whole infrastructure and all the processes around that. We've now built that for you and shown you how to do it so that you can take it over and you can learn and do it yourself. So ultimately, that's our goals for our customers to own these systems when we leave.
All good points. Now, one other question, because we have great discussions so far. I'd like to talk to you all day, but we're limited by time. So 2 things. We talked a lot about history and data, and then we also talked about generative AI. Do you think there's a future, an application to be able to leverage generative AI to build missing data sets?
I think there is, and I think it is not explored yet at all. So let's dig a little bit under the covers of what the underlying innovation of generative AI was. The fundamental innovation that made generative AI possible is an ML algorithm called transformers. And transformers was really the magic. That's the magic under the covers. And the reason why we talk about generative AI as an umbrella term is that it's not just for generating text. The same underlying transformers is that's the same technology that allows for these text to image generators, the text to video generators. It's all transformers was the thing. Similar to how autonomous AI is built on deep reinforcement learning, that was the innovation that made it all happen. Transformers is what makes generative AI possible. And all the focus has been around generating images and generating text and whatever. But I think, to your point, I think that we have not done enough research into how to leverage transformers to generate other types of data. And in that case, I think there absolutely is similar to how, if you think about it, let's put it in terms of things you've probably seen already. You probably have seen where they're able to take damaged photos, right, from World War II or whatever, and they're able to run it through AI, and it's able to clean that all up, right? And how does it do that? I mean, it literally has to fill in data that's missing. It fills in gaps in the data when there's tears in the photo and stuff like that. It's able to fill in those gaps and make a reasonable looking picture out of it. That same thing could be done with gaps in process data, right? And we could generate realistic data and fix some of those issues with that. So I think that there's a ton of value in leveraging transformers on data rather than just words. And I'm excited to see where researchers go with that.
Yeah, and that's a good point, right? Because we talked about all this absence. So if you can at least spoof some of that and get that time to value kind of decrease, leveraging Gen AI on the front end, I think that's a great use case, because again, it's not the goal is not to get that hallucinogenic data from it. It's just like, hey, here's like a week's worth of history, throw some anomalous variables and create, a 2-year trend or something like that. And now I can get into that refinement, throw some disturbances, do all this. Like, that's where I think it becomes kind of cool. I also like, once we can build the roles in to get away, like just say, I don't know.
Yes.
It will. I think there is a good future for some of what you mentioned before on the training and the maintenance optimization. But I love the, your thought on this mind share capture. Everybody's been trying to figure out how to capture mind share from experienced operators. They're never going to get that same womb to tomb kind of employment cycle that people have been accustomed to. Everyone's like a 2-year contract employee right now.
Yeah.
So, building that historical database, working hand in hand with that process expert to deliver these models is something I think a lot of people miss, right? You can't take that. The humans know, like they don't even know that they know every little tweak that they're making and how it does, because it's just like breathing now, right? You're unconsciously conscious of your abilities to perform that system. So trying to take that out and putting it into like those machine learning models, I think is a great place to start.
Yeah, and I'll build on that and say that in some cases, I mean, I've got customers that basically see it as an existential threat. That when they lose those experts, those last couple experts that they have that know how to run that line, like you said, like breathing, like they know, oh, whenever I turn this knob, I always do this one 2%. Like they just know how to do all that. And all those people are retiring. We've lost, they call it the silver tsunami. We've lost all of that expertise since COVID. I saw a report that was, a research report that I had to go back and look at the data because I really didn't believe it at first, that said the average tenure before 2019 was 20 years in manufacturing, and it's gone down to 3 years of experience in the folks that are coming in. We've lost all of that expertise. And so many of my clients see it as existential. They have two choices. They're either going to capture that expertise from those SMEs in Silicon, in AI, before those experts leave, or else they're just going to have to live with the fact that the line is never going to run as well as it does today. And those are their options. And so while it's not the whole story around how we solve this problem of the loss of all of this expertise, it's not the whole story, but it is part of the story. I do think that AI is going to play an important role in making sure that we can continue to operate, we can continue to manufacture. And these are our clients. I mean, you guys have lived in this world, as long as I have. Like, I love this world of manufacturing. I think it's so critical. It is the lifeblood of any economy. And I don't want to see it, the losses in productivity and that's going to affect everyone. Costs are going to go up, and the quality of products, we're already kind of starting to see some of these product quality issues that are seeping out into the real world and the mainstream. And that makes me real scared. And when I walk into these companies and I talk to these clients and I go, well, who knows how to do that? And they go, well, it was Joe, but he retired 2 months ago and all we have is all the papers that are scattered on his desk. Like, that's real scary. And I'm seeing that over and over again. So I do feel like AI is an important part of moving us forward, and getting to a point where we're back to being able to produce like we have been, and we kind of take for granted the last 20 years. I want to make sure that we can continue that upward slope.
So maybe, Bryan, we can close on a philosophical note here. So it's great to have folks like you on the bleeding edge, doing all this discovery, trying new things. But I also want to tie it back to this sort of old school philosophy. So, within lean, there's the word genba. Genba in Japanese means go to the place of work, see for yourself. And I think that it seems, at least to me intuitively, it seems like you still need people to help ensure that your models are tied to real world, right? Yes, you're trying to replace people or augment people and do these things, but making sure that there is a check to the fidelity of your models to actually what is going on in the real world.
100%. Expertise, human expertise is not going away. We still need experts. I was in a webinar yesterday and they asked me, if I'm a 20-year chemical engineer, am I going to have a job? I'm like, if you're a 20-year chemical engineer at a company, you have the most job security of anyone in the world, because they don't have your expertise anymore. So there's no question that we're so far away from the sci-fi world of artificial general intelligence where, these AI models are going to take over for humans. It's just, we're not anywhere near that right now. Expertise, human ingenuity, human creativity, all the tools that we have today are not going to replace any of that anytime soon. So I 100% agree with that philosophy. We need to get out there. We need to see this stuff working, and we need to make sure that we're incorporating AI. It's not the only answer to this. It should be a part of your whole digital transformation approach. So, yeah.
Yeah, definitely agree with that. Now, Bryan, you shared a lot of good examples. You're very mature in this. Where can people kind of reach out and find you, learn a little bit more about what you're doing, potentially help them with some of what they're going from?
Yeah, so they can always, my company is Rovisys, so it's ROV as in Victor, ISYS.com, Rovisys.com. And then they can always look me up on LinkedIn, Bryan DeBois, BRYNDEBOIS on LinkedIn, and feel free to reach out to me there. And happy to talk to anyone about this stuff.
And just a little bit about Rovisys in general, like what's the size of your company? Are you a small mom and pop shop, or are you do one-off projects? 1,400
engineers globally, about 18 locations around the world, headquartered here in Cleveland, Ohio. That's where I work out of. When I started 24 years ago, we were about 100 people, I think. And so it's been great to watch the growth of our company over the years. We work in all the major manufacturing industries. So everything from life science to oil and gas to consumer packaged goods to metals and mining. I mean, across the board, we've got expertise across all those different industries. So happy to have somebody reach out.
Awesome. Well, thanks everybody for tuning in to this episode of Practitioners Unplugged. We hope you found these stories and insights as inspiring and informative as we did. Don't forget to subscribe, leave a review, share the podcast with your network. And until next time, keep innovating and keep transforming. Thanks again, Bryan, for joining us.
Happy to do it. Thanks, guys.
Been a pleasure, Bryan. Thanks.